Okay, here we go. So finding the equation of the axis of symmetry, right? This is a different way of doing it, where you don't have the vertex, no vertex. Okay, that's how this is different. Okay, since a parabola is symmetric, points on either leg are equidistant. Sorry, I just had to sneak that one in. They're same distance away from the center. That's what that's saying. Equal distance, okay, from the axis of symmetry. If you are given 2 points that have the same y value, and I'm going to highlight that part, have the same y value, okay, they are at the same height essentially, we can find the value of the axis of symmetry using this formula. We take the first x value, the second x value, and simply split that in half. But I would strongly encourage you to put, I don't have to do this, the brackets. Whenever there's addition, either in the numerator or denominator, there are invisible brackets there. You should be doing that first before you do anything else, okay? But this is the equation. And so where x is the axis of symmetry, x1, x value of the first point, and x2 is the x value of second point. So you're basically finding the average, the middle between those 2 points. Okay. And so let's look at this graph underneath here. So make sure we put our arrowheads there. Okay. And I want you to, if you have a ruler, I would like you to use it. If not, just be careful here. But let's say in this particular instance, if you look at these 2 points, you should notice that they both have the same y value, right? They both have the same height. And that allows us to find a center. So I want you to kind of draw a line connecting them like that. Okay, so they are exactly at the same height, opposite each other. Okay, then let's go to the other points right here. You notice that both of these points have the same height as well, 5, right? And let's make a line connecting those as well. Coincidentally, what's this point right here? Let me zoom in a little bit. The 0, 5 is what do we call that? Our y-intercept, right? It's our y-intercept. So the y-intercept has a point across from it. And so now I would like you, if you have a different color, let's draw our axis of symmetry. We know that our axis of symmetry would be going through the vertex, right? So imagine the vertex is right here. Grab your ruler and then draw, I'm going to draw a dashed line through it. Okay. So in this case, I'm giving you a graph. So I know you can tell right away what the axis of symmetry is, because this point right here is 2, 3, right? We know that our vertex is 2, 3. So therefore, the axis of symmetry is x is equal to 2. But what if you wouldn't have the graph? What if I just gave you a pair of points like this? Okay. You should note that this distance is the same as this distance here, right? Like if you go from the center to this leg or the other leg is the same. Down here across, the distances are the same. So as long as you're at the same height, they're all the same. You could have multiple examples of this. I'm just picking 2, okay? So using 0, 5, and 4, 5. Okay? If you have these 2 points here, for example, okay, we will make this our x1 and this our x2. So the y values do not really come into play. They're just there to tell us and to confirm that they're at the same height. They're opposite each other. So to find the axis of symmetry, we would simply go x1 plus x2 divided by 2. So you know that that's 4 divided by 2, which is just 2. Okay? That's one way of doing it. Or using the other pair, negative 2, 11. Make sure you write this down, okay? And 6, 11. I know I need to move my camera, sorry. I'm zoomed in, so I gotta be a bit careful here. If you were given these two, you would still call this your x1, and this is your second x. And it doesn't matter if you were to flip them, if you make this your x1 and that your x2, you still get the same answer, so don't worry about that. But the axis of symmetry here would be negative 2 plus 6 divided by 2. Negative 2 and 6 is 4 divided by 2, which is just 2. So what have we just done here? What have we accomplished? We were able to algebraically figure out our axis of symmetry. Okay, we're good. So let me zoom out, and we could practice, and I always have more examples than what I need just to make the point, right? So let's say you're given 2 points, find the axis of symmetry, and again, you should recognize, hey, 7 and 7, same height, right? Across each other. Okay, the same height tells you that they're just on opposite sides of the legs, right? They're looking right across, right? They're cousins, I say, right? So this is your x1, this is your x2, right? So to find the axis of symmetry, you just go negative 4 plus 5 divided by 2. And that is just 1 over 2. So you're technically done, right? You could write x as 0.5 if you'd like, but there's that. By the way, what have you just found? You actually now know, if I ask you, hey, what's the vertex? You're now one step closer to figuring out the coordinates of the vertex. You just don't know the y value yet. But you do know the x, right? Because remember, the axis of symmetry, right, is the x value of the vertex. So you're kind of getting closer, and that's where we're leading towards. We're trying to see, hey, what's the vertex? Well, I can do this and find that. Now I'm just one step away from finding the y value. Okay. Let's keep going. I'm not going to do that one because it's the same thing over and over. It's just add, divide by 2, add, divide by 2. We've done 3, so let's keep going. What if, though, how can we apply this to this scenario right here? So go to page 12. Go to page 12. And what if, how can we apply that to this scenario? So watch this. Both of these points that you're given have the same y value, so they're across one another, and you're given the vertex. Same thing. This is going to be our x1. This is going to be our x2, x sub 2, right? And so what is this? The 6, the vertex. What is that? You guessed it, it's x. It's the axis of symmetry. It's what we're actually finding all along. But now we know that, right? This is the axis of symmetry. So as you can tell, we will use algebra to figure this out, knowing that x is equal to x plus x1 plus x2 divided by 2. Okay. The axis of symmetry is 6, so plug 6 in there. x1 we know is 3. We don't know what x2 is, but we know all of this is divided by 2. So substitute. Sub in, right? That's what I did there. I substituted in the values. And what should you do when you have something like this? Get rid of what first? I'm going to get rid of that 2. So I'm going to multiply both sides by 2 to cancel out these ones. 3 turns into 1, right? 2 divided by 2 is 1. So you're left with 12 on that side, and then it's 3 plus x2 on this side. And then subtract both sides by 3. x2 is equal to 9. Okay. So the second point is 9, 5, right? Like we were wondering what that is. So it's 9, 5. We just found it. So axis of symmetry works that way as well. You now have 3 points, which is, can you remember this? For the parabola, we need 3 points to come up with its equation, and we're going to do that. Calculator will help us do that. So now you have 3 points. Just let's finish this. That way I have covered everything I needed to cover today. So given f of x is this, you should recognize it's in general form because there are no brackets. Describe the direction of the opening, width, and y-intercept of the parabola. Well, it's going to go down because a is negative. This you already know. It's going to be wide because a is between 0 and 1. And what's the y-intercept? 0. There's a 0 here as a constant, right? So 0, 0 is the y-intercept. And here is perhaps something that's a little new to us. This is, you haven't seen much yet. Determine f of 3 and f of negative 4 algebraically. What are you finding? So let's do f of negative 4 first. If we run out of time, you've done the more challenging one. F of negative 4 is telling you that you're going to insert negative 4 wherever there's an x on the original equation, right? So x squared, so negative 4x squared, right? Plus 12.5 negative 4. I'd like you to put brackets in whenever you're substituting into an equation like that. And let's do this in steps. So grab your calculator. I'm going to go negative 0.02 times negative 4 squared. And that is negative 0.32 plus, on the other side, 12.5 times, you got to watch out here, you're multiplying by negative 4, not minus 4. Watch what happens if you go minus. Syntax. If it allows you to go to the mistake, it'll tell you what it doesn't like. So it's negative. So it's 12.5 times negative 4, and that's negative 50. Whoa, what's this? Negative and positive. I don't like that, right? You know opposite signs, when they're next to each other, it's always negative, right? Positive times negative, so it's just this. So it's negative 0.32 minus 50. So that's negative 50.32. Before you pack, hold on. What did you just find? What is this? That's y. Yeah, that's y. So you found, this is important, you found a point on the parabola, which is what? X is what? -4, and Y is -50.32. That's what you just found. And you're already on the quitting time mode. So there's your homework, okay? I want you to try that or do some graphing. It's up to you.